Okay, so we have to discuss this topic. This is a new topic, the last topic of general physics. That is actually the pressure. So when we talk about pressure, pressure is divided into uh, three classifications or three categories in our syllabus. I will talk about that, but first, let me introduce pressure to you people. Actually, when we talk about pressure, pressure means that how much force is applied per unit area of a body. In this first paragraph, in which I have just put that when we are going to have the introduction of the pressure, here are some examples. For example, when you are going to push a drying pin into a piece of wood, what do you I mean, what do you observe? That thumb pin is not being, it is not damaging your hand or thumb, but it damages or it enters in that wooden piece because force you are exerting on the thumb pin is same as it is exerting on the wooden piece as well as on your thumb. But the problem is that pressure is different. And when the pressure is different, due to that, where area will be more, pressure will be less, and where area will be less, their pressure will be more. So pressure is that quantity which actually depends upon force and area both. That is why I just define pressure, that the pressure is the force per unit area, perpendicular force per unit area. Actually, it is categorical definition that this makes the pressure different from stress. When I will use this word, na, perpendicular. Perpendicular means that if there is an object, for example, you have a knife and you must apply a perpendicular force on its edges to cut the piece of paper or piece of wood or whatever you are going to cut it. So that makes it pressure. The perpendicular force acting on a unit area of the surface of the body, that makes it pressure. Okay, so its formula is defining formula is force per unit area. It's very simple. SI unit of the pressure is, what is its SI unit? Its SI unit is Pascal or Newton per meter. You have to keep this, unit in mind, and this formula in your mind for the calculations. This is the general formula of the pressure. Wherever you will see that pressure is acting, you will use that formula. Then Pascal and Newton meter per square, Newton per meter square is basically its unit. It is a scalar quantity because we do not have any value in the specific direction. It is just so pressure in yes, what I was talking, that we will talk about pressure in the liquids, pressure in the solids, and pressure in the gases. So here we go. We will deal with pressure in the solid first. First, what we will do, we will talk about pressure in the solids. So in solids, the perpendicular force is applied on a specific area. Let's see. This is very interesting diagram. Usually, we do not explain that perpendicular concept of perpendicular force, but you must know this thing, that the force is applied on this specific unit area. That is why the pressure is being developed. If I will change the direction of the force, the pressure would be changed. And if I will change the area, pressure will be changed. If I will change the quantity of the force, pressure will be changed. And its example is in front of you. On this carpet, there is the same piece of concrete or the wood, but it is placed in two different orientation or in different dimensions. In dimension number one, when it is vertically on its vertical edges, like sharp edges like this, in let me call it figure number one. Okay, what do you expect? This is, let's say, figure one. The weight is acting on this much area. This is the area at which weight is acting upon. So when I say that this area is 20 centimeter into 50 centimeter square, so what is area? Area is 20 times 50, right? And when it is laying down like this, weight is same, force is same in this case. So this is very important, that force is equal in both of these cases, right? And that is 11.1 kilonewton, which is basically 11,100 newton. That is the force of this concrete block, and that block is actually placed in such a way that it is on its face 50 times 100. So now it is 50 times 100 square centimeter. So what do you expect? Where will be the least pressure? On in figure 1 or figure 2? This is figure 2, right? Without knowing physics, just what is your perception? What will happen?
More pressure on.
Pressure will be more on one, because
Yeah.
the force is on very small area, right? So when force is at very small area, pressure will be more. So let's have the calculations for this problem. The in diagram number one, this is the calculations for figure one. That is 11.1 into 1000, just to convert from kilonewton to newton, right? I have converted it from kilonewton to newton. And area is, yes, the important thing in this all topic is conversion of area. So when you are going to convert area, first of all, I will recommend that this is 20 centimeter. So if that is given in 20 centimeter, just consider it 0.2 meter. And if it is 50 centimeter, what is that? 50 centimeter. So just consider it 0.5 meter. Is it clear to you?
So always it should be in meters.
Yes, it must be in meters. When it is in meters, what will you think? I mean, what will you have? You will have the unit Newton per square meter, na? Or you will have the unit in Pascal. Okay? So if it would not be in standard units, your final unit will not be Pascal. Is it? Are you getting it?
Yes, sir.
Okay. So what pressure do I have? I have the pressure of one one kilopascal. I mean triple one kilopascal. Right? It's a simple calculation. Now, what about this? In diagram number two. In diagram number two or in figure number two, we just put the body um, in such a way that its area has been increased 100 times 50 into 10 raised power 4 is basically some conversion from centimeter. So it, you can say 11.1 into 1000 divided by 0.5 times 1. So you will get this number. So do you see that the pressure has been doubled? 11 point, sorry, reduced a lot. It is 11,100 pascal, or sorry, one triple 1,000, 111,000 pascal. So simply, if I just consider it in kilo, so it is 111 k pascal, and it just tripled 22.2 kilopascal. So is it clear to all that what happens? That when we are going to have, or when we are reducing the, sorry, increasing the area, actually the pressure is reduced. Is it clear to all of you?
Yes,
So
sir.
this is actually that all discussion and
Sir, but the
conclusion.
I'm sorry to interrupt, but
No issue.
uh, figure point two has more area, right?
Yes, more area, na? Almost how much area? It is 50, so 50. So its area is 20, so its area is 100 times. So its area is multiplied by 5. So pressure should be reduced by 5, isn't it?
Oh, okay. I get
You
it.
got it? Yes.
Yes.
So when you will divide this 111 with 5, just see what do you get. Yes. What did you get?
22.2.
That's it. So conclusion is that when you have increased, if area is increased by any number, let's say 2, then pressure will be reduced by 2. And if area is increased by, let's say, 5, pressure will be reduced by 5. So I believe that it is very simple concept and you people will get it.
Yes, sir. But sir, can you show the figure for a second?
Yes.
Mm, yeah, done.
Is it clear to everybody?
Yes, sir.
Okay. Okay. Now, the second situation, our second, uh, uh, I mean, perception is, our second assumption is pressure in liquids, right? What we have to talk about? Pressure in liquids. So, when we discuss that, how to handle the pressure with liquids, actually, we mean that pressure liquids would have some pressure. Actually, gases also have pressure, right?
Yes.
But when we talk about, I mean, when I will get into detail of that, then you people will know that it does not matter. In air, pressure will be very small because there are some factors which affect the pressure. So one of them is that in liquid or gases, they are called fluids, and in fluids, the pressure is due to three things, right? One, the height, yani height of the column of that, which is actually, or which is usually called depth below the surface of the liquid or depth below the surface of the air. Second is the density. It's very important topic. I mean, yes, it's density. Density matters a lot. If the density of the fluid is greater, there will be greater pressure. Okay, you will have more pressure on that. And the third one is value of gravitational acceleration or value of G, which is not actually that much variable because most of the time value of G is same, right? Most of the time, what is value of G? Value of G is same everywhere. So we must now, or we must think about that, that the pressure depends upon several factors. Just go through this slide quickly, then it would be more clear that when the substance flows, then we have noticed that the just like water from for the right, it has mm, it covers less distance when it flows out of the tube, and the water which is leaking or flowing out of the second tube, it is traveling to a larger distance, isn't it? Did you notice that? Is
So
it?
I
Did you notice
think
that?
think get the diagram again.
I mean, in diagram number left diagram, did you notice that the water is the water which is getting out of the tube leaking हो रही है यहाँ से from this point which is falling down here. This water is not having that much force or it is not traveling covering a lot of distance, but this is falling at a larger distance. I mean, yeah, exactly. It is a larger distance.
Oh yeah.
So, what is reason behind that? The reason behind that is, I mean, what is the obvious reason? Because in both tubes we have water, but the height of water above this hole is greater than height of liquid above this hole. So it means that the I mean to say that the pressure, why this water is falling out more, because it has more pressure. It's very obvious, because it will have more pressure on the writer diagram, isn't it? Here
Yeah.
you can say that pressure, let me call it pressure 2, is greater than pressure 1. Here it is pressure 2, and this is your pressure 1. So the only reason, obvious reason what I can have here, that is that is that is what?
That the height is more.
Height. Yes, that is the height. Okay.
Yes, sir. But like, if the pressure is more, that means that it spreads over a large area.
No, no, no. In liquid, area does not depend. I mean, does not matter. Just three factors I told you. These are the three factors here. The pressure of the fluid column depends upon three factors, and those three factors are, one of them is density, second one is density of the liquid, first one I mean, second one is height of the liquid column, right?
Hmm.
Height of the liquid column, I told you the depth of the liquid actually. The point where we are going to measure the pressure, na, above that there will be a depth of liquid, is it?
Yes.
So that depth is called height of the liquid column above that point. Is it clear to all of you?
Yeah, but sir, like in the figure up, like the second diagram, the
Mhm.
distance was more, right? Like the what
Yes,
height
height was
more,
more.
the pressure
There
was
was a,
more, and it's
yes, I mean, I can just make you clear that when you are diving deep into sea, you face more pressure. Nothing happens, neither your area, neither density of the liquid. Just what changes, that is the depth below the surface. Right? Do you get it?
yes,
So when you people have more water above your body, what you have? You have more pressure. Is it?
uh-huh. Got it, sir.
Got it? Is it clear to everybody? Everyone in the class? Or there is no one in the class? Haji, Khadija, who is there in the class? Okay. मरियम आपको आवाज आ रही है मेरी?
Yes, sir.
Who is in the class? Let me
Khadija,
check.
sir.
इससे सारे ही हैं
सारे ही बोल नहीं रहे हो तुम लोग, क्यों? खैरियत? नाराज हो
Sir,
मुझसे?
Ariba and Zainab are not there, and Ariba is here. She just joined, and
Okay.
Khadija is here.
Okay.
Yeah,
Okay.
sir. It was telling me my microphone was having issues and it kept saying refresh the page. So I did.
Okay. Okay. You did. You follow instructions from computer, but not from me, right? Refresh it. Okay, very good. Nice. So we were talking about the pressure is fluid, pressure on in the fluid is height of the column, right? Which I have explained that what does it mean by height, then density of the fluid and gravitational. So due to this all, you just get a single equation that pressure of the liquid is equals to rho gh. What is the pressure of the liquid? Pressure of the liquid is rho gh, where rho is, what is rho? Rho is the density. Okay, I have mentioned all these points here. Rho is density. Okay, This one. H is the height of the liquid column above the point where you are considering the pressure, and G is the gravitational phase strength. Right? Is it clear to you? Okay. So right after that, we just go
Sir,
to yes,
can you show the diagram above? Like those of two
yes,
curves.
sure. This one.
Yes, sir. Done, sir.
Okay. Okay, done.
Yes, sir.
Okay. Now the important thing what I want to share with you people here, that pressure does not depend upon the shape of the liquid column, right? In all these, check, they have different areas, they have different shapes, but if they all have same vertical height, they will have same pressure. This is remarkably important, that if the column height, this is actually the height of the column, if the liquids have same height from bottom to top, whatever their shape is, whatever their height, whatever their size is, most important thing, most of the time students are just confused, sir. It has very large area. I mean, there would be more liquid in that, so it must have greater pressure. But no, it is not like true. It will have no impact. Area does not have any impact, whether you are swimming in a swimming pool or you are swimming in the open sea. If the water density is same and you are at the same height, or sorry, same depth from the surface of the liquid, you people would face same pressure. Is this very clear to everybody?
Yes, sir.
Yes,
But sir,
sir.
So
how is the vertical length same? I mean, the last beaker, for
this
example,
thing.
is curved, right? So if you like straighten it, for example,
No,
you'll
no, no,
get.
no. You're not going to straighten it. Whatever the angle is that. What is the vertical height of the top of the liquid to the bottom? That is the height which ensures the pressure. Are you getting it?
Yeah, so the shape does not matter.
No. Shape, area, it does not matter. Or volume of the liquid. Is this very clear?
Yes. So what
So I
matters
have
is the
mentioned these things,
vertical height.
that cross sectional area, no volume, no. The only thing which is important, yes, no shape, whatever the shape is, right? That does not matter. Only thing which matters is the level of the water, vertical height. Okay,
Yes, sir.
okay. So in the next slide, I have shown you uh, a diagram. Okay, that is the properties of the liquid. That's a summary. See, if I say that there are different holes at different positions, the water has the largest pressure at the bottom of the container, where the height of the column is largest. See, this is the, I mean, this is the depth of that point. So if more will be the depth, more will be the pressure. Is it? Is this very clear to everybody?
Yes, sir.
Okay, so actually, this is a there is a relationship um, between the depth and the pressure, which gives you the gradient or envelope, right? So here we have least depth, height is minimum, then pressure is minimum, right? Is it clear to you?
Yes.
Okay, so
Sir, but again, I have a question.
yes.
Uh, the like, can you scroll down a little bit? second to see that. Yeah. Uh, Sir, the one in the bottom, it it is spread over a less distance, but the one at the top is spread over a large distance. So is it
No, no,
that
no,
it's
no.
the like
This
it
one is
goes towards
spreading.
the
Hmm. This one
it,
is spreading. Uh, you can say this. The P1, it is spreading till this point. Okay. And if we say that P4 is spreading more, P4 should not be at this point. Actually, P4 should be larger than that. That's why the gradient will meet it over here. That is just, I think, a wrong placement of pressure. Good,
uh,
very good identification. You got it?
uh,
So, because when I will join the gradient, na, I have to join it because as I have shown you that it depends upon the gradient. So it must be something over here. Here. Got it?
yes, but if the pressure is more, it will spread to a more distance, right? As
Yes,
it
exactly.
looks in the
It will
diagram.
go more. जैसे आपके पास होता है ना, when you have a pressure gun, right? So you can throw water at a larger distance.
Yeah, that was what I was asking.
Yes. Okay.
I got it.
So the pressure
Can you show the
transmitted.
diagram?
Yeah. ये तो मैं notes भेज रहा हूँ मैं. So if you are going to write and draw it, don't do that. I am
Oh,
sending.
okay. Then fine.
Hmm. Your duty is just to focus and understand the things. Writing के लिए मैंने ये काम किया हुआ है ना. So why I have wasted my time? इसलिए कि बच्चों को सहूलत हो थोड़ी सी. Okay, so we are moving to the last aspect of this, that pressure is transmitted through the liquid. Pressure acts in all directions. These are the actually summary of the pressure as I have given the name to the topic. That is that it acts in all directions, right? Then all points at the same depth, they have um, same pressure, and the pressure increases with depth, right? Pressure increases with depth. Pressure does not depend upon shape of the container. So simple derivation of the formula for it is hydrostatic is a word which I have used, the water at rest. That is rho gh. Okay,
Yes, got it.
got it. So that is basically it is very simple derivation. If you just go through that, it's quite easy, right? How? Just go through that. uh, Actually, the weight of the water is acting on a specific area, na? For example, this is the container of the water, and its all weight is acting at this area. This is the weight, and this weight is acting at this area. So can I say that the force is weight force? What is force? Force is the weight force, isn't it? Force is the weight force, and weight force is acting on an area. So I can simply say that pressure is equals to force per unit area. So weight divided by area, and weight is mass into value of g divided by area. And what is mass actually? Mass is density into volume. So weight will be density into volume into g simply. So this is till this point, I have just given the value of your weight. So if I say that pressure is equals to mass is density into volume into g divided by a, and from here pressure is equals to rho, as it is density volume is area into height into g divided by a, and you will simply cut area with area, and you will get pressure is equals to rho gh. It's very simple derivation, and if you people have any confusion, I can recalculate that pressure is equals to force per unit area. Force is equals to weight divided by area, and weight is equals to m into g divided by area. Are you getting my point?
Yes, sir.
Okay.
Sir, but the
So
force is not always weight, isn't it? Or is
no,
it
no, no.
always
In this
weight?
case, weight of the liquid. So it is m into g divided by area. Okay. And what is mass? Mass is your mass is density into volume. I use different colors for different notations. G divided by area. Okay. And let's say the volume. Let me put it with green for you. Volume. Okay. This is your volume. And finally, this volume is actually what? Area into height. Okay. I'm just replacing this volume. Green को मैंने replace किया. Then density will be written as it is. And then value of G will be written as it is. And divided by A will be written as it is. Are you getting my point?
Yes, sir. Got it.
Okay. Now your area will be gone, area will be cancelled by area, and you are left with rho g h. That is the equation of pressure. Okay, is it clear to all of you?
Yes, sir.
Okay, so that's it till today for today's class.
Sir, are you saying something?
Sir,
Because,
you're frozen.
yeah.
My Siri just responded to me when I was trying to talk to Sir. Sir's left the meeting. What do we do?
I don't know if that was an internet issue or an intentional leave, but
I mean, last time it had also happened like this, where Sir had like left and then we just ended up talking like for an hour or so. He didn't come back.
yeah, but like, I have no idea. He came back.
Okay, Sir's back.
Yes, yes, I'm back. Okay, so what I was saying that yes, that's it for today's class. And my laptop just followed my order and it just shut down. Okay, so I hope that till this point you people will have no issue at all.
Sir, how much pressure is left?
Pressure, atmospheric pressure is left, and then we have to talk about the measurements of the pressure. Um, Actually, these manometers and barometers have been excluded, so I will just skip them out. Right, and this
Oh,
hydraulic
sir, why is it
press
so
is
long?
no. Hydraulic press is also gone. So finally,
Sir,
this
do we
is
have
that
Boyle's
point.
law?
What do we have?
Do we have Boyle's law in our syllabus?
Yeah. Boyle's law is basically the pressure in the gases.
Uh, okay.
Okay.
Yeah.
So inshallah, in next lesson it would be done. It would be completed.
Okay,
I'm going
sir.
to send you the notes. So meanwhile, if you go through these notes and just practice the questions, it would be fine. वैसे तो मेरी क्लास होगी ही ना इंशाल्लाह. So we will do it.
Okay, sir. Got it.
Okay, see you then inshallah.
Okay, see you.